Good morning, students. So, in the last class, we discussed about the purification of compounds by using different techniques. Okay. So, in the today's class, we are going to discuss with the last two topics of this organic chemistry, some basic principles and techniques in organic chemistry. So, one is qualitative analysis of hetero compounds and quantitative analysis of hetero compounds. Quality means what? What are present in them? If any organic compound is there, as I told you, in the organic compound, carbon is there, hydrogen is there. Along with carbon and hydrogen, oxygen may present, sulfur may present, phosphorus may present, nitrogen and halogens may present, like heteroatoms. Heterocyclic, I told you, in the initial classification, homocyclic means only made up of carbon atoms. The compound consists of only carbon atom. Heterocyclic means along with the carbon atom, at least one is another other than carbon atom, like oxygen, sulfur, phosphorus. For example, listen, this benzene is an example for homocyclic compound because all are carbon atom here. Similarly, these three are benzene, one is replaced by nitrogen. This is heterocyclic compound. R. This is heterocyclic compound. Understand? So at least one of the atom is replaced by any other hetero atom other than carbon. Hetero means different, homo means same. So if such a type of compounds are there, how can we how can we test? So which compound consists of, because organic compound is, we cannot distinguish whether carbon is present, hydrogen is present, oxygen is present by seeing our eyes. By seeing with our naked eyes, we cannot distinguish. Understood? Only by through the chemical reactions, we can check which element is present other than carbon and other than hydrogen, whether it is present or not. So there is some tests are there for particular for oxygen different is there, for phosphorus different is there. So we have to conduct those tests. If that test is given the result positive, then the respective element is present. If it is the result is negative, then it is absent, like that. Understood? So I hope in the 10th standard you already know the gases formed. Okay, so if H2 gas is formed when zinc is treated with any H2SO4 or HCl. Okay, so zinc solution, zinc granules are there. Those zinc granules are treated with any acid means H2 gas will form. That H2 gas is confirmed by which, so here zinc granules is there, assume here one, any, what is it, contain is there, anything is there, to that acid is added, then H2 gas is liberated. So here we are inserting a tube and the tube is directly inside the water. When the H2 gas is formed, then your bubbles are formed. By bubbling that water, we can confirm SH2 gas is liberated. Similarly, if any HCl is liberated, understand, if any halogens are there, to that acid is added or anything is added, HCl will remove. So HCl removed means what happens there? Sorry, not HCl, Cl will remove. Or CO, for example, listen, here you take Na2CO3. To this Na2CO3, if you add any acid or it may be a base. Okay, acid you add because this is a base, you take acid. It forms NaClCO2 plus H2. NaClCO2 plus H2. So we have to confirm CO2, evolution of CO2. We have to confirm what we will do. So we will take insert here CO2 is formed. It is inserted again in a test tube. The test tube containing what? Lime water. If the lime water turns milky, then CO2 is confirmed. If lime water doesn't turn milky, then CO2 is absent. That is one test. So this is the way to do the test, and also the confirmatory test whether if here it turns milky, then only CO2 is liberated. We can assume like that. If the result becomes negative, means this is absent. Here also bubbles are formed, then we can confirm H2 is liberated. If it is not formed, then H2 is not liberated, like that. Understood? So this is what, and we cannot see how the reaction takes place inside. We cannot see zinc, how it is converted to zinc sulfate or zinc chloride. If we use H2SO4, it changes to zinc sulfate. If we use HCl, it changes to zinc chloride. We cannot see that how it is changes, but we can observe that indirectly by formation of the bubbles. Understand? Okay. So similarly, like that, for these hetero compounds also, particular what is the reactions are there. So that is called qualitative analysis of organic compounds. 2 marks important. What? Qualitative analysis of organic compounds. Okay, so listen, quality means what is all present in that, If any students is there, if you want to say that quality, of course, is good in reading, is good in that subject, this subject, we will say like that. Similarly, what is that quality means? What is that particular organic compound mainly consists of? Okay, so listen, of course, that organic compound means then carbon and hydrogen are common. They have to present. Then only they are said to be organic compound. So initially, we are going to reduction of carbon and hydrogen. Okay, so students, initially I write test here and here it is confirmatory test. What is the test? So your organic compound is the, to this organic compound we are using copper oxide. When this organic compound is mixed with this copper oxide, then in this organic compound, what I consider here, carbon and hydrogen. Okay, we don't know whether other atoms are there or not. If present, if carbon is there, hydrogen is there, sulfur is there, assume. Even though sulfur present, with the CuO, only carbon and hydrogen react. Understood? Assume there is other heteroatoms is also there, in this sulfur is also there, phosphorus is also there, nitrogen is also there. Still we don't know. But by this reaction we can confirm presence of carbon and hydrogen. Only carbon and hydrogen get reacts with this CuO. This is a particular test for carbon and hydrogen only. Okay. So the next, we don't know this carbon. Okay, I'll write here this carbon compound consists of carbon, hydrogen, nitrogen, sulfur, phosphorus. Okay, so initially we have to convert carbon and nitrogen. So this is the test. Organic compound plus Cu. So what happens there? Listen, Cu, if it reacts with carbon, it is a good reducing agent. So it forms CO2 plus 2Cu. One reaction. Next, if CuO is there, if it is react with hydrogen, hydrogen is in H2 form. It forms H2O plus Cu. Understand? That is 2H. Why? Because we cannot take H2 here, because the organic compounds are like this. Correct? So whatever the carbon is present, that is completely converted into CO2. Whatever the hydrogen is present, that completely converted into H2O. How it is confirmed? How can we confirm? The carbon is converted into carbon dioxide only, and this water is hydrogen is converted into water molecule. That is what confirmatory test. So this CO2, if it is treated with calcium oxide, calcium hydroxide, so it forms CaCO3, the white color precipitate plus H2O. This is what? Turbidity, white color. Lime water turns milky. What I said, okay? So this is called lime water test. This is called lime water So the CO2 is formed here. The CO2 gas, this is evolved here, which is passed into what? Lime water. Okay, that lime water, if it turns milky, okay, this is what precipitate. Why it turns milky? Because of the formation of calcium carbonate. Calcium carbonate is insoluble in water. Understood? So because of this reason, it forms turbidity. If turbidity forms, lime water turns milky, the CO2 formation is confirmed. Understood? And second one is conformity test for formation of H2O. Okay, so we are going to add copper sulfate here. Okay. We are going to add copper sulfate to H2O. I will take 5 moles of H2O. Why? Because this will form a complex. So it forms Cu H2O 4 times SO4 into H2O. So this is blue in color. So means when you add copper sulfate, if the solution turns blue, that confirms what? Of course, this hydrogen is converted into water molecule because this is the reaction taking place. They form a complex. The color of this complex is blue color. This is what test and the conformative test. So in the organic compound, how can we consider or how can we test the carbon and hydrogen? Means by treating them with what? Copper oxide. All the carbon is converted into carbon dioxide and all the hydrogen is converted into water molecule. Okay, so that is confirmed by this complex test and also lime water test. Okay, so this is what carbon and hydrogen. So next, I'll go to another. I'll go to another one test, that is this one. Initially, the carbon and hydrogen is directly tested like this, okay? But remind the nitrogen, sulfur and phosphorus, so and halogens also. Okay, they are going to convert into, of course, there is covalent form. Okay, nitrogen, sulfur, phosphorus and halogens are in covalent form. Initially, they are converted to what? Ionic form. How? By treating with sodium. Okay, so students, these are subjected to Lagrange's test first. From this Lagrange test, we are getting sodium fusion extract. Okay, so I will tell the process first. So sodium fusion means what? Mix up, extract. We are extracting the fusion of those compounds with sodium. That's why it is called as sodium fusion extract. What is the procedure for that? Listen, procedure is not necessary, but I will explain. So a small fusion tube will come. In that fusion tube, we have to insert sodium metal, a dry sodium metal. Understand? So that dry sodium metal to that tube, again we are adding the organic compound what we have. If only this much of tube is there, very small it is. So this much of tube, in that we have to insert sodium metal along with that organic compound. Because we have to fuse the respective hetero compound with that, what is that, sodium. Okay, then that fusion tube is heated to red hot condition. What is that red hot means? If we keep on eating that, what is that fusion tube, it becomes completely red. Understood? So due to that heat, it becomes completely red. So when it becomes completely red hot condition, we have to pour that, what is that, fusion tube into a distilled water. Only if the tube is only this much means a 50 ml of water is enough. And less than 50 is also enough, 20, 25 ml. Or one test tube of water. One test tube of water, 13 ml. So we have to pour that pour that red R2 into what? The distilled water, and we have to crush it. Okay, when we crush that, all the organic compound which is present in the sodium, it is completely clearly mixed with that. Then we have to filter that. When we filter, the glass particles in the fusion tube is filtered up and the filtrate left. That filtrate consists of the filtrate nothing but sodium fusion extract. So what is that filtrate consists of? It is nothing but a liquid. Understand? So what is the filtrate consists of means when the sodium it is fused with nitrogen. So it is not only fused with nitrogen, along with carbon it fused. So it forms NaCN, cyanide will form. Okay? So when the sodium, if it is fused with sulfur, it forms Na2S. Okay? So sodium is there. If it is fused with halogen, it forms NaX. Okay? Sodium is there. If it is fused with phosphorus, it forms Na3P. So this is what in the sodium fusion extract, what are the reactions takes place? They are, if you dissociate this, Na plus Cn minus to Na plus S2 minus, Na plus X minus. Here, the covalent compounds is converted into what? Ionic compounds. Understand? This is the main thing we have to do to identify a qualitative analysis of the hetero compound other than carbon and hydrogen. Okay, carbon and hydrogen directly detected or identified or tested by using copper oxide. So we will discuss one by one. Initially, detection of nitrogen. Right. Detection of nitrogen. Students, concept. You just remember this. I want so much space, so I will start with the initial. Detection of nitrogen in the test. So listen. So students here, I will write SFE. What is that? SFE means sodium fusion extract. Sodium fusion extract plus, okay, ferrous sulfate. Ferrous sulfate means FeSO4 followed by and acidified with concentrated H2SO4. This is the test we have to conduct. Sodium fusion extract is mixed up with what? Fused with what? Ferrous sulfate or reacted with ferrous sulfate, and later it is acidified with concentrated H2SO4. Then what is the reaction takes place? So in sodium fusion extract, if nitrogen is present, how it is converted as NaCN. Correct? We don't need Na, we need only Cn. Okay? So consider Cn minus atoms. Okay? So when it is treated with Fe plus 2 ions, or you take just NaCN only you take. FeSO4. Understand? What they will form? Okay? So FeCN6 4 minus. It is a complex. Plus we just take balance because we cannot balance here clearly. Fe plus 2 ions. This is the reaction after that because we are going to use H2SO4 also. So by taking that, here in this reaction we cannot balance. Here also SO4 is there. In H2SO4 also H2SO4 is there. Correct? So this sodium combined with both the SO4 and form Na2SO4. Okay? Alone in this reaction we cannot balance them. So that's why I'll take only ions. From NaCN, Cn minus N. From FeSO4, Fe plus 2 ions. Okay? Next what happens? So this is acidified with. Initially what happens when SFE reacts with ferrous sulfate, this type of complex will form. So this complex Fe Cn6 4 minus, when it is acidified with what? Concentrated H2SO4. So students, when it is acidified with concentrated H2SO4, some of Fe plus 2 ions of this FeSO4. Listen, FeSO4 is there. If it is treated with H2SO4, they form FeSO4 thrice, Fe2SO4 thrice plus H2 like that. Means the plus 2 oxidation state changes to plus 3 oxidation state. Okay, what are the oxidation state and all? I'll explain in the redox reaction chapter. Just remember, it changes from plus 2 to plus 3. Means 1 electron, it loses 1 electron. Plus 2 to plus 3 means positive charge increases means what? It loses 1 electron. So here, some of the Fe plus 3 ions is going to react with them in the second reaction. Initially, when SFE reacts with FeSO4, this complex will form. When it is acidified with H2SO4, what happens? This complex combined with Fe plus 3 ions. So students listen here. Here it is plus 3. Listen, A minus 2, B plus 3 is there. How can you balance? So here it is 2, here it is 3 means you just cross multiply. You write A3, B2. Correct? Here I write. So Mg plus 2 is there. Cl minus 1 is there. Here 2, here 1. How can you balance means by cross multiplying MgCl2. Are you getting? By cross multiplying the valencies of the elements, we can get the formula. Here minus 4 is there. Here plus 3 is there. Okay? Then this is Fe4, Fe Cn6, 3. Are you getting? I'm just cross multiplying the charges. Fe4, FeCn6 twice. Okay, so this is Russian blue color.